We've looked at a lot of chemical reactions so far, and we've seen that they can be endothermic or exothermic, meaning they can absorb heat or they can release heat to the environment. We haven't looked at exactly the mechanics of how these reactions take place, and that's what we're going to do now as we try to balance these chemical equations. So we know that methane, in the presence of oxygen, will form carbon dioxide and water. But how much oxygen is required, and how much carbon dioxide or how much water will be produced by this reaction? What are the ratios of those quantities? And that's what we're trying to figure out when we balance chemical equations, is in what ratios or in what proportions will these substances combine and recombine? Well, as is often the case, the best place to start is at the beginning. So let's look at the methane molecule, the first molecule there. That's one carbon atom combined with 4 hydrogen atoms. And we see that on the right side of the equation, we have a carbon atom over there with the carbon dioxide and 2 hydrogen atoms connected to the oxygen and water. Well, the carbon then is balanced. There's 1 carbon on each side of the equation, so that makes sense. But the hydrogen atoms, 2 of them just seem to disappear into thin air. Well, since we know that can't be, we know that in this equation, we must get 2 water molecules every time we burn 1 methane molecule. So we're going to put a 2 in front of the water molecule there to show that we're getting 2 H2O. And so we've accounted now for the carbon and the hydrogen, but we have to make sure we also account for the oxygen in our equation. So if we have 1 carbon dioxide molecule on the right side and 2 water molecules, that means we're going to have a total of 4 oxygen atoms on the right side of the equation. And you can see there are only 2 on the left side of the equation in that 1 oxygen molecule. Well, that means we just have to double the amount of oxygen that we're assuming is going to be in this reaction. So that tells us that 1 methane molecule is going to need 2 oxygen molecules in order to burn. And when it does, it's going to produce 1 carbon dioxide molecule and 2 water molecules. So we can see then the proportions that these molecules are going to have to combine and recombine in as this chemical reaction takes place.